Hello everyone. Welcome to the lecture on the implementation of the chi-square test of independence in spreadsheets. We are going to look at the implementation of the chi-square test of independence in Microsoft Excel first. So we have the example from before. So we have the list of cities and the brand preferences corresponding to each city. Note that this is a hypothetical data set. So we have the following data set where we have the list of cities and the brand preferences corresponding to each city for a particular person. So we have to calculate the observed frequency in this case. So the first step is to calculate the observed frequency. The reason is that we are trying to comment on the population based on the sample. So we have the sample in here with the given data set, and we are trying to understand whether the different cities have any impact on brand preferences. So with this sample, we are going to conclude for the population on whether these two categorical variables are independent or not, right? So the null hypothesis in the chi-square test of independence is that the two categorical variables are independent, and the alternate hypothesis is that they are not independent. So we can calculate the values as follows. We have Mumbai and Chennai and brands to be A, B and C. So we have the observed value here. So we use the count ifs function to satisfy a certain criteria. So the first case is we want Mumbai and A, right? So we can do this equal to Mumbai and brand to be equal to A, right? So this is how we calculate the observed frequency for Mumbai and A. So I now log these cells so that we can extend it across the other combinations. So we have 279 for Mumbai and A. We can drag and drop across other cells. So we require Mumbai and B in this case. So this will be Mumbai and B. This will be Mumbai and C. This will be Chennai and A. This will be Chennai and B. Make sure that you change the brand here. And finally, this will be Chennai and C. So we have the joint distributions for the observed frequencies. Now we require the marginal distributions corresponding to each brand and each city. So which is the sum of the columns here and the sum of the rows here. You can just use the drag and drop feature of Excel, which will help us do this. And you also calculate the overall sum. So this is how the observed frequency table will look like. Next, we need to calculate the expected frequency. As pointed out earlier, we are going to look at the sample and then comment on the population. Therefore, we need to calculate the expected frequencies. And the expected frequencies are calculated using the marginal distributions, right? So in the first case, where we have Mumbai and A, this will be the value here corresponding to A and corresponding to Mumbai divided by the total, which will give us the expected frequency corresponding to the combination Mumbai and A, right? And as you can see here, the denominator is going to be common across different combinations, and we need to drag it across E4, then F4 and G4. So this E4 needs to be dragged across. So I don't fix that, but I fix the other value here. So that is how I'll calculate the value corresponding to Mumbai. Similarly, for Chennai can be calculated as E4 into 403, which is in H3, divided by the total, which is H4. Again, the total is not going to change, so I fix this, and H3 is also not going to change, so I fix this, and you can drag it across, right? So now we have calculated the observed and expected frequencies. Now we need to calculate the chi-squared value, right? In order to do that, we first obtain the observed minus expected the whole square divided by expected for each cell. So what is the value corresponding to Mumbai and A? It is in E2 minus Mumbai and A expected, and then we have the square term here divided by expected. So this is what is the first value, and we drag it across the other cells and obtain these values. So the chi-square calculated value will look something like this. So this is the sum of all these values. As you can see, this is 7.009. You can go back to the lecture and verify that it indeed is 7.009, right? Now, we need to look at the tabular value of the chi-square. So the tabular value of chi-square can be calculated using the inverse function. So we have the level of significance to be 0.05 and the degrees of freedom to be 2. Why the degrees of freedom is 2 is because we have two cities, Mumbai and Chennai. So 2 minus 1 becomes 1, and three brands A, B, and C. 3 minus 1 becomes 2. So 1 corresponding to the city multiplied by 2 corresponding to the brand will give us the degrees of freedom. And we obtain the degree chi-square tabulated value to be 5.99. Since the calculated value of chi-squared is greater than the tabular value of chi-squared, we can conclude that the null hypothesis is rejected, right? So is there a way where we can perform the chi-square test directly instead of performing these additional calculations? We do have a chi-square dot test, so which asks us to give the actual range. By actual range, we mean the observed frequencies, and by expected range, we mean the expected frequencies. And you obtain the p-value directly in this case, right? You obtain the p-value directly, and since this p-value is lesser than the level of significance 0.05, we can reject the null hypothesis. This is what you conclude by directly calculating the p-value from the observed and the expected frequencies. So this is how you implement the chi-square test of independence in Excel. Can you perform the same test on Google Sheets? Of course, you can do so. So since these count ifs are directly following here, I'm going to just copy the values in this table directly here onto Google Sheets. So this is just for you to illustrate that this chi-square dot test also works on Google Sheets. So we first have the observed frequencies, and we then have the expected frequencies, and this directly gives you the p-value, right? And you can also do the other way, the longer method, where you have chi-square dot inv, which is the inverse 1 minus the level of significance, which is 0.05, degrees of freedom is 2, right? We have taken 5.99, and you know already that the chi-square calculated value turns out to be the sum of all these values, which is 7.009. And again, the null hypothesis is rejected. So this is just for you to know that the same method can be implemented on the Google Sheets as well. So the commands corresponding to chi-square.test or the chi-square.inverse also works on Google Sheets. So this is how you implement the chi-square test of independence on spreadsheets. I hope you like this lecture. Thank you.